Let's look at one more aspect of interfaces here around these mechanics and semantics, and they have to do around the empty interface and type assertions. Let's take a look at some code. So what you see here is that the print function is able to determine, and it uses reflection to determine what type of data it's being passed in. And you can see if I display between lines 13 and 16 a string, a numeric, that float, right, or Boolean, that will print out, and print is smart enough to know how to do that. But what if we wanted to implement our own version of FUMPT in like our own call, my print line? You can see here I'm passing the same exact values through. How could we do something similar to what print does? And if you also notice, the print function in both cases is accepting all kinds of data, right? And it's not necessarily based on what it is, and it's also not necessarily based on what it does. We just have to accept everything and then try to figure out what it is at runtime. And we do that by leveraging the empty interface. So if you look on line 37, the myPrintLine function is now accepting data not based on what it is, but kind of funny enough, also not really based on what it does. It's using the empty interface. And the problem with the empty interface is that it really describes nothing. It's not suggesting that data has to be behaving in any sort of way. It's a very generic way to bring data in, and most of the time when we're using this, we're going to have to leverage the reflection package or something like type assertions to figure out how to act on this concrete data. So here's a case where we're passing concrete data through this polymorphic function, but not really based on any specific data, but in a more general way. Now this is really dangerous stuff. If I see code like this, and marshalling and unmarshalling and reflection is not really being used, it's probably going to put a hold on the code review. But look at what we're doing here. We're saying, okay, pass any type of concrete data you want through this. I don't even care what it does. It can do nothing, and that's okay. But now we have to inspect this data at runtime, and that's where a type assertion comes in. Now, I'm showing you a special type assertion here. I mean, one way to do a type assertion, and we could do it right here, is to be very, very explicit and say, hey, does the concrete data inside of A, is it a string? So we could do a type assertion like this and be very, very explicit. Is A a string? And if it is, then V will be a copy of that data, that string that we've stored inside of A. Remember, it's always going to be moving copies. In this case, however, if A is not a string, this program is going to panic. We have an integrity issue. That's no good. So there are times where you want to maybe test something and you're not 100% sure it really is going to be in there. We can use that second form, which is the Boolean flag. And now if OK is true, there was a string, we get it back. If OK is false, there wasn't a string, we won't get that string back. V will be of the empty, right? That zero value, an empty string. OK will be false. But what's really cool is instead of doing conditional logic on the OK variable, go as this special mechanism on the switch. And what this does is it says, let's do that same type assertion. Let's do it in a generic way. Let's type assert on the keyword type. And then inside of a switch case, we can ask, hey, if we perform this type assertion, is the data inside of A a string, or is it an int? Is it a float, 64? And if it's any of these, then let V be a copy of the data of that type. And let's execute this code. And in the default case, what we're saying is that it's unknown. So look how cool this is. We can see the output of our FUMPT program. There it is, just like that. We can also see the output of our myPrintLine, and not only are we displaying things like FUMPT, we're also able to use this %t formatter, like I'm showcasing on line 40, and also identify that that was the type, even on the unknown side. All this is being done either in this case through type assertions. We can also leverage the reflection package to do this. So the empty interface is a way of saying I will accept all concrete data, not by what it is, not only, and also not by what it does, just bring it in. But now we know nothing about the data, so we have to leverage these types of type assertions, which is bringing copies of that data back out of the interface, whether it's a value or a pointer, or we can start leveraging reflection as well.